Thanks for this opportunity. At this moment, I'll try to dive into the presentation. Yeah, so my presentation is going to actually based on three things. One, I'll just give a high level introduction on building speech recognition systems. Then I will try to give an example application of speech recognition for social impact. Then I'll probably show you how we are trying to build open source datasets so that we can have a sustainable chain of building speech recognition systems and retraining them with more data. Yeah, so that is going to be the core of my discussion for today. So my name is Jonathan. I've already been introduced. I'll jump to this. So we could be asking ourselves, why voice technologies? So voice is the future. So the future is voice. And we're getting into a situation whereby there is need of building human machine interaction for with voice devices. We all understand we have already devices that exist like the Google Assistant, Siri, and Alexa. But these can't really be built for our local languages. You find that such services are mainly available for the major languages across the world. And actually, you will find that not all languages, but mainly languages like English. So this kind of makes it imperative to think about this when it comes to the local languages, if we are to solve the day-to-day problems in the developing countries. If you look at another challenge that is really available there is that most of the existing data sets that actually are available are biased. They tend to work for men much more than women. So this is a gap, and also they don't put in a consideration of accents. Yeah, so this kind of builds this gap in the existing data sets. And just to mention this is that however much I'm saying existing data sets, they don't really exist. Some are behind the buildings of these big companies. So they're not really open so that people can build solutions to solve problems in the developing world. Yeah, so this kind of brings a huge block for innovation and speech, especially speech innovation. For our case, if you look at Uganda, we have over 40 languages, and all these are under-resourced languages. So how can we try to build speech technologies that can really work for us here in a language, in a land with over 40 languages, and these are under-resourced. So for this presentation, I'm really going to focus on Uganda, which has over 8.5 million speakers, and it's from the language family of Niger Congo. This is really important because when it comes to building technologies or speech models for low-resource languages, we try to take advantage of transfer learning, and you find that most of our languages actually are from the same family. They have the same alphabet. So this is really something good for us to prioritize or take advantage of. Yeah. So what is a minimum viable voice assistant? If you look at a minimum viable voice assistant, imagine that you have your input. So maybe someone is speaking through a voice assistant, you kind of have a speech recognition model. So you have this speech which you give to your speech recognition model. And wherever you see numbers, most likely you need a model. If you look at steps 2, 3, 4, and 5, at least you need one machine learning model there. And if we look at the speech recognition, hopefully your speech recognition model is going to correspond. It's going to give you text that corresponds to what actually someone says, and not basically give you random letters. You wouldn't like to have that. So from this text, you really want to get an understanding and get meaning out of what someone was actually saying, the intention. So you want to extract some meaning from it. Yeah, so there you need to apply some natural language understanding techniques. Yeah, so there you also need kind of another model. So from there you have this, you've derived some meaning from this, but then based on the meaning you get, you want to kind of take some actions, and then you have to do some natural language generation, which is more of having some set of rules or some kind of stuff like that. So you have now this text from what you've actually tried to understand from what came from the speech input. And from this text, you want the assistant to talk to your user. And that's where now natural language generation comes in. As in, that's where speech synthesis again comes in. Yeah, so now, if you look at speech synthesis, you really need some good amount of data, and this has to actually come from particularly some good amount of data from one speaker or two speakers. You don't need a lot of speakers. You need very quality data sets. You don't need background noise. Yeah, so not every data set can work for this. So for this presentation, I'm going to focus mainly on speech recognition, building speech recognition models. Yeah, so just to show you a simple application of where this can be applied, in our case, you want to build a speech recognition model, so you need a data set. If you look at the existing data set that's out there, like LibriSpeech, the switchboard corpus, LibriSpeech, these are mainly like taken from audiobooks and people are just reading, so which doesn't actually, it's not representative of the real world. If you look at the switchboard corpus and the feature corpus, you kind of need some licensing. If you look at the Google commands, you simply have these commands, English commands. So basically this can't work for us here. So this kind of brings in another blocker, and this is more of transcription. So you need to kind of build your own data set. It takes a lot of time to build a good quality data set, which you have to use to train your models. And you need a team of linguists to try and transcribe this. So this kind of is also another challenge that comes with these languages as well. Yeah, so we try to, that's why it's really important to think of transfer learning when it comes to these languages, because if you have a good model in one language, you can do some transfer learning and have another model which you can use in another language. So now you have your transcribed data set and your audio data set, which you are going to use for training. Yeah, so the case I'm going to try to use as an example for social impact is where we try to use a radio for crop disease surveillance. And in such a case, we had to build a Uganda deep speech model. So basically what happens in this is that you have your model, your speech to text model in the pipeline that kind of consumes radio streams that come through, and then it gives you text. Then you have two options. You can either, for example, the model that we use for deep speech, there's a provision of taking advantage of the hot words feature, whereby you have the hot words you're interested in or the keywords, or you may just transcribe the audio files. And once you transcribe these audio files, then you can filter for the keywords you're actually interested in. Then you can do some analysis around this. Yeah, so in our case, we were interested in crop diseases. So we had this intention of understanding which crops are people talking about, what diseases are there any kind of locations that are being mentioned. So once we mine this radio data, we try to analyze the keywords, try to see whether we can get some insights that could be used by the policymakers, or try to understand if radio can be another good data source where we can try and use do crop disease surveillance. Yeah, so you have these keywords you're interested in and you want to actually filter them out through these audio signals. Just to briefly talk about deep speech, I won't say much about it. Put in a link there. You can read about it. So it is an open source speech to text engine. It is based on Baidu's deep speech paper, and it uses Google's TensorFlow, which kind of makes it easier to use. There are quite a lot of other tools like SpeechBrain, the Cowdy toolkit, all those are available. So it's up to you, and basing on your expertise and the data set you have, yes, and the resources you have actually, to see what approach you can try and use. Yeah, so you have your training data. In our case, we had over 120 hours of transcribed data. And as usual, you have to split this into the train and test and validation test, validation set. For radio, it's kind of interesting when it comes to the data set. It's a tricky data set because you have to make sure that your test set, if you want to get that's a test set where you don't have in the training set. Yeah, so when we did this, we had a 0.65 word error rate. Yeah, so you find that you have a huge data set, but you don't necessarily have a good word error rate. So this means that you need to keep improving your model by feeding it more data and data. So this calls for a sustainable kind of way, because getting data is not that easy. So I'll kind of dive into that at a later stage. So we tried to do a pilot on this, and what we did was to mine radio data from the southwest. I think it's more of central, but southwestern Uganda, around there, one of the districts. And then we try to understand what were actually people talking about. Excuse me. So from this, if you look, we try to look at the data and try to see what districts are coming up, because we are particularly interested in the location of the diseases, where these disease mentions are coming from. So we are able to get this from radio to filter this out to understand, okay, from the very many conversations we've gotten from radio about agriculture, which locations are being mentioned. And then we try to understand what crops are being mentioned. And from this, you can see people are talking more about tomatoes, about coffee discussions coming through. Yeah, so it's now comes zeros down. If you are interested in a particular crop, then you could try to go down and try to understand what are people talking about tomatoes, what are people talking about maize, what are people talking about coffee. Yeah, so then we try to also understand what keywords are being used a lot. And in this, you can even try to categorize the keywords if you really want to see keywords about diseases, which keywords are being mentioned, how come certain keywords are not coming up. So when it comes to keywords itself, it's also another kind of process, because these keywords keep changing and you need to keep refining and refining. So that's why having a speech to text system is better in most cases than having just a keyword spotter, because you have these keywords that keep changing always. People keep coming up with new names to diseases. Sometimes people don't know the diseases. Sometimes the diseases are new. And you want to be in position to capture these keywords. Yeah, so after getting all this, we kind of tried to map our data together with data we're getting from other source, which was image data from crop diseases. And we try to see, okay, if you have this image data that comes through about farmers sending through images about what crops, what diseases are affecting crops. And we also try to see on radio, can we see if there is a match? Yeah, and it so happened that we found a match, though there weren't many because this was more of a pilot on the radio side of things. This is more like 1 month's data and it's one radio station where we have over 15 radio stations. Yeah, so so if you look at this, we're able to find something about the fall armyworm being mentioned in a district where we also got kind of feeds about the fall armyworm from the images, but it also was kind of cross-cutting from the report we got from radio. And someone was saying like we are being challenged by insects, many of them, some have attacked the leaves. Even those who plant maize have a challenge of the fall armyworm and the termites. So, so it's kind of a proof that radio can also be used to do crop disease surveillance. Yeah, so there's a lot we can do with speech technologies or models. So ideally, in a country where we have over like 40 languages, we are able to build different models, and this is one way we can try to apply speech recognition to have social impact. But now this also calls to have a sustainable model of building better speech recognition systems. So we need data to train our models, and we need to be collecting a lot of data. So this takes me to Common Voice. So just talk to you about Common Voice. So Common Voice is Mozilla's initiative to democratize speech technologies. Yeah, so what we actually did was to take Luganda to Common Voice. And on Common Voice, what actually happens is that we have very many people, like Luganda speakers, they come over and start reading sentences. This in one way helps us to kind of work out on the challenges I mentioned earlier on, like bias. And yeah, so the end goal is to have a representative data set that can actually, so that we can use usable speech recognition systems. So we have different people come to this platform and they start reading these sentences in Luganda. And as they're reading these sentences, they are recording themselves. So in the end, we have a text and we also have audio. So on the other side, other people come and validate whether these people who are contributing voices actually read the sentences in the right way. And once we have this, we have our data set. So at the moment, we've managed to collect over 80 hours, which are available for download, but of these 80 hours, 31 hours have been validated and therefore they are usable. You can use them to train your speech recognition model. But on the other side, we have more hours that are not yet downloadable, but soon they will be downloadable. So this is in one way is more of a sustainable model to continue training our model. So just to take you over through this activity workflow. So if you look at one, you collect and validate the sentences, you put them out there to the public. So the people or the speakers with different accents, different gender, different age, they come and read these sentences as they record themselves, and these sentences are validated. So from this, you generate a data set and you train your machine learning speech to text models. Then it continues. So it's a loop. As people are collecting more sentences, as you're putting out more sentences on the platform, people are reading more of the sentences and they are recording. So you're building, you continue training your model. So in the end, you have a model that can actually work and be used for social impact and for many other things that people, researchers, developers are actually interested in. Yeah, thank you. I would like to thank Mukiibi AI Lab for making this work happen. Bill and Melinda Gates for supporting this. Radio Simba gave us radio data, working with Mozilla on the Common Voice platform, and Makoni Lab as well. Lacuna Fund, Fair Forward, and The Independent. Yeah, thank you.